Now here we have quite a tricky problem from the 2000 paper, and it's one that you should definitely try yourselves before looking at the solution here. It involves some tricky algebra. Okay. We're told that a stone is projected vertically upwards with initial speed of u meters per second, and it rises 70 meters in the first t seconds, 50 meters in the next t seconds. Find the value of u, the initial velocity. To start off with all these problems, same thing, always write out the equations. And what we have is v is equal to u plus at, v squared is equal to u squared plus 2as, s is equal to ut plus 1/2 of at squared. Now it's a matter of looking at it and picking which equation will be the best for us. Well, we're definitely looking for something with u, we're looking for something with t, and we're looking with something with s and acceleration. So I'd say this one here has to be the one that we're looking for. Possible to do with other ones, but this is the one we'll work with. Now, what we know. So there is one piece of information there that isn't really given as such, but it's been shown vertically upwards. So acceleration, the only accelerating acting on it would be gravity, which would be minus 9.8. I'll just round it up to minus 10 meters per second squared just for this problem here. If you're doing the problem in the exam, I'd use 9.81. But okay, so we've got s is equal to ut plus 1/2 at squared. Now there's two sections to this, so I'm going to use that's the first section and then that's the second section. Now the way I do this is to kind of imagine the first displacement, s1, is equal to 70, u equal to u, t is equal to t, a is equal to minus 10 meters per second squared. Let's put meters in there. Now the second section, I'll do it in a different colour and I'll do it just beside it here. S2 is equal to 70 plus 50, which is 120 meters. U is still equal to u. The time in this case is 2t, and the acceleration is the same. And the reason why I've done it in these two sections, you'll see in a second, is that we're going to end up with some form of simultaneous equation. So when you've got two unknowns, you need to use simultaneous equations to work them out. So I'll do the first one in black like I started. So we've got 70 is equal to ut plus 1/2 at squared, 1/2 at squared. So we have 70 is equal to ut minus 5t squared. Now I'll go with the next one and I'll continue with the colour scheme. For this one we've got 120 is equal to ut, in this case it's 2t, it's twice the time has gone over, plus 1/2 at squared, so it's minus 10. Let's redo that. Minus 10, and t squared, in this case time squared is 2t squared. So we just want to be careful of that squaring. So we've got 2ut plus 1/2 of that would be minus 5, and then 2 squared would be 4, and then t squared. So we'll have 120 is equal to 2ut minus 20 t squared. Now I'm going to number these two equations. We've got equation 1 here and equation 2 here. Now this isn't really a simultaneous equation like you'd be used to seeing. You could try to get them in terms of each other and substitute them in and all the rest, but it'll work out quite awkwardly. Best way to do this one, I think anyway, is to multiply equation 1 by 2. What happens when we do that? Let's have a look. So we'll have 2 by 70 is equal to 2ut minus 10t squared. Now I'll go back to the black there just so that we can see it, so it's the same, you know it's coming from that. 140 is equal to 2ut minus 10t squared. Now, looking again at this one here. So, what we could do is, like a simultaneous equation, subtract equation 1 from equation 2. Now, equation 1, I'll write it in black again. If I multiply it by minus 1, well, no, I'll leave it as that. 140 is equal to 2ut minus 10t squared. And I'm going to use minus equation 2, which would be minus 120 minus 2ut plus 20t squared. Add these together, and what we'll get is 4, 5, 6, green pen 5. We'll try, and we'll get 20. They'll cancel. Is equal to 10t squared. Divide both sides by 2, so that's just a little equation. We'll just do a little bit of rejigging on that. So 10t squared is equal to 20. T squared, divide both sides by 10, is equal to 2, and t is equal to root 2 of a second. We'll leave it in that form just for the time being. Now the next thing we want to do is just to sub t is equal to root 2 and back into either of the two equations. I'm probably going to pick the first one because it's the simplest. So we'll go with that. 5, so subbing back into equation 1, we get 70 is equal to ut times root 2 minus 5 times t squared, so root 2 squared. It's always a good idea to include the brackets and take your time with those steps. They're very easy to make a mistake in them. Root 2 u minus 5 times 4. So I'm just going to move them around. 2 root 2 is equal to minus 20 is equal to 70. Add 20 to both sides, and you get root 2 is equal to 90. Or u is equal to, let's move this down, u is equal to 90 over root 2, which should be equal to, doing your calculator, 90 is 45 times 2 over root 2. Root 2 over root 2 is the same as 2 over root 2 is the same as root 2. So you get 45 root 2 meters per second, and that's the answer.